Hello, Algebra 2. Hope you guys are having a great day. Today I'm just going to go over a problem with, like a word problem with piecewise functions and talk about domain and range a little bit. And that's about it. Just kind of like applications of piecewise functions a little bit. So this example is about the postal service, which charges 42 cents for any letter weighing up to 1 ounce. So that's like a typical letter. And then after that, for additional weight, it's 23 cents per ounce. And it says measured continuously, which means that if it's 1 ounce and 1/10 of an ounce, then you pay 1/10 of 23 cents. So it just kind of like accumulates continuously, as opposed to as soon as it's over an ounce, then you have to pay 42 cents plus 23 cents, which is going to be a question later. So depending on how the money is charged, then you're going to have different functions for it. But in this case, it's measured continuously. And then letters over 6 ounces don't qualify for these rates. Okay, so number one, how much does it cost to send a 1/2 ounce letter? Well, if it's 1/2 ounce, it's less than 1 ounce, which means it's going to cost 42 cents, right? Okay, number two is how much does it cost to send a 3.5 ounce letter? And this is above the 1 ounce, but less than 6 ounces. So this applies, this is the situation that that they gave us. So it's 42 cents for the first ounce, and then after that it's 23 cents per ounce. So since this letter's 3.5 ounces, that's 2.5 ounces over your original 1 ounce, right? So you have to pay the 42 cents plus 23 cents times the additional, right? So that's times 2.5. So for the 1 ounce, it's 42 cents, and then for the additional 2.5 ounces, it's 57.5 cents. So then you can add those two together and get your total cost for this letter. Okay, adding those together, we get 99.5 cents, but dollars, use in context. If you're doing something with money, only round to the nearest 2 digits, because that's how money works. Unless it's gas, sometimes they go to the thousandths. But for us, mailing letters, they're not going to charge you 1/2 cent. So we round that to 5 and above, give it a shove, 4 and below, hit it down low. Okay, so you round it up to exactly $1. Okay, next question says, what is the piecewise function of the cost of a letter weighing X ounces? Okay, so your independent variable is the number of ounces, and your dependent variable is cost. So I'm going to start with cost equals, and I'm going to start with a little bracket because we know it's piecewise, so we're going to need to have a bunch of pieces. Okay, in this case, we know we have 2 different scenarios. Okay, the first one is the letter is less than an ounce, and therefore it is 42 cents. Okay, so the cost, if my weight is between 0 and 1 ounces, you can't have negative weight, so your domain is not going to be negative. So you're only going to be dealing with values of X that are between 0 and 6. Because remember, 6 was letters over 6 do not qualify for these rates, so they're not a part of this domain. Okay, so the first scenario is the weight is between 0 and 1 ounce. And that's what this says. It says the cost is 42 cents if X is between 0 and 1, if the weight's between 0 ounces and 1 ounce. Okay, if X is larger than an ounce, then and less than 6 ounces, then we need a different function. And so now we need to figure out what that function is. Just keep in mind that I have this less than or equal to on 1, because if the weight of the letter is exactly 1 ounce, they'll still only charge you 42 cents. However, if it's more than 1 ounce, then they will charge you in the next bracket. So let's figure out what that function is. Okay, so to figure out the equation of this function, I'm going to draw a little sketch of the graph of what it might look like, right? Because we know it's a line, and basically you know that when that it's increasing for every ounce, right? So if my x-axis is my ounces and my cost is my y-axis, I know that for every ounce increase, there's a 23-cent increase. So that means that my slope is 23 cents, or yeah, 23 cents per ounce. Okay, so you should know that the slope, I'm looking at main ways to write this function. I have y equals my slope, which is 23 cents, times the weight, plus we don't know what the y-intercept is, and that's something that we do need to figure out. Okay, so in order to do that, I think it's really helpful to graph it. So we know that from 0 to 1 ounces, right here, the price is 42 cents, okay? And at 1 ounce, still 42 cents. After that, then, it increases by 23 cents per ounce. So that brings us to 65 cents for 2 ounces, then 88 cents for 3 ounces, $1.11 for 4 ounces, and so on. Okay, so now in order to figure out what the y-intercept is, I do not trust my graph, okay, so I'm not going to eyeball it. I'm actually going to algebraically solve for it. So I know that part of my equation is that is what I have here, right? 23 cents times x plus my y-intercept. But I know that it goes through certain points. I know that it goes, for example, through the point 2, 0.65, right? 2 and 0.65. So I can just plug that in and figure out what my y-intercept is. Okay, so if I plug in that point to 0.65, then I just solve for b. b is 0.19. So my final equation is y equals 0.23x plus 0.19. Okay, so then we need to use that in our piecewise function, and there you have the piecewise function for this scenario. Okay, number 4 asks, how would it change if portions of an ounce were not counted and anything under a full ounce was rounded up or rounded down? Right? In this case, you're going to have somewhat of a step function. So instead of a basic linear function right here, you're going to have steps, right? You're going to go from 1 to 2, 2 to 3, 3 to 4, and then the rounded up and rounded down, what that changes is where the hole is, right? So it might be like this, or it might be like this, depending on what scenario it is. I'm going to let you guys figure that out, because I don't want to give you too many hints. Haha. Okay, last thing I really want to talk about is domain and range of a piecewise function. And this may be difficult or it may be easy depending on how much you understand about domain and range already. Remember, your domain is all of your possible x values. So where is the function defined in terms of x? So like, if I'm only going along the x-axis, I want to know, where do I have graph? Where does the graph exist? So I'm traveling along the x-axis from negative infinity to positive infinity. So I'm like this little dude or dudette, I'm a dudette, walking along the x-axis, right, starting at infinity. And you want to know, at what point does the function start occurring? Oh, it starts happening at 1. Okay, 1 is included because there's a closed dot. So you know your domain to start is going to be from 1 to we don't know where. And keep going, figure out, does it stop anywhere? So from 1 to 3, it looks like fine. There's a function there. And then at 3, you have to look up and see, make sure that the function's defined. And it is, because there's a closed dot at 3. So it's defined there. It's defined from 3 to 8. And it's also defined from 8 to 11. But there's not an arrow at the end of the function, right? It's not there. So it doesn't keep going, which means the domain stops at 11. And because there's a closed dot at 11, we include it. So our domain is from 1 to 11. The range is going to be the same question, but in the y direction. So instead of me walking along the x-axis, I'm going to be walking up. I'm going to be flying up the y-axis from negative infinity to positive infinity. Okay, and I want to see, where do I have function? Where does the function exist? Okay, so here's my really ugly birdie flying from negative infinity all the way up to positive infinity. At negative infinity, there is no graph. It doesn't exist, right? If I were to be at negative infinity and look across into the abyss of function land, I would see nothing, right? So then as I float up, you want to find the lowest point that the function starts existing. And I think in this case, it's at 2 where it hits the function right here. Okay, so then we keep going and we keep figuring out, are there holes anywhere else? Okay, so my guy keeps moving up. Here looks like something funky's happening because you touch the graph, you see the graph a bunch of times, but it still exists, and that's all we care about. So we keep going, just keep flying, just keep flying, just keep flying. I'm gonna bring him up. And here we still have function, and we stop. Oh, looks like here we've got a changeover from this point, but it's also defined over here. So we don't have a gap there at all. So that's still included in the range. So then we keep going, just keep floating up, all the way up, until we see the end of the function. And right here, at 12, that's the end of the function. So we didn't have any gaps that we don't need to exclude. But if we did, we would need to use the union, right? Like negative infinity to union 2 to infinity, or whatever. Okay, we've done that before. You've seen that before, so hopefully that shouldn't be anything new to you. If it is, come see me. Anyways, so that our range is literally from the bottom of my graph, which was down here at 2, all the way up to the top of my graph at 12. The thing is, it doesn't include 12, because that's an open dot. Therefore, our function, the range is from 2 to 12, not including 12, which means an open parentheses. And I believe that is all, friends.